Since the dawn of humanity, we have gazed up at the vast, star-dusted canvas of the night sky. We have watched the sun make its daily journey from east to west, bringing with it the warmth and light that sustains all life. These grand, celestial rhythms have sparked a fundamental question within the human mind, one that has been pondered in every culture across every continent. What is the nature of the world beneath our feet? What is its shape? This inquiry into the shape of our Earth is one of the oldest scientific and philosophical quests in human history. It represents our species' journey from simple observation to complex reasoning and, eventually, to empirical verification. The story of our planet's shape begins deep in antiquity. Early civilizations, from the ancient Egyptians to the Norse, conceived of the world as a flat plane. The Babylonian maps, some of the oldest we have, depict the world as a circular, flat disk surrounded by a bitter river or ocean. However, around the 6th century BC, a revolutionary idea began to take hold among the ancient Greeks. Thinkers like Pythagoras and later Plato proposed that the Earth was not a flat disk, but a perfect sphere. In the 3rd century BC, the brilliant Greek astronomer and mathematician Eratosthenes performed a remarkable experiment. Using simple observation, he calculated the circumference of our planet with astonishing accuracy. The great voyages of discovery, like Ferdinand Magellan's circumnavigation of the globe in the 16th century, provided the ultimate, practical proof. His fleet sailed west and, after a long and perilous journey, returned to its starting point from the east. In our modern age of satellite imagery and global communication, it may seem surprising that the idea of a flat Earth persists. Yet it does, supported by a community that questions the mainstream scientific consensus. From our limited human perspective on the ground, the world does indeed appear flat. The curvature is not something we can perceive in our immediate surroundings. Within the flat Earth model, familiar concepts are reinterpreted. The sun and moon are described not as massive celestial bodies at immense distances, but as small, local light sources, moving in circles above the disk of the Earth. The boundary of this flat world is often depicted as a colossal ice wall, which we know as Antarctica. This wall, it is argued, holds in the oceans and prevents anyone from falling off the edge. One of the most elegant and ancient pieces of evidence for a curved Earth can be observed at any seashore. Watch a tall ship as it sails away, out into the open ocean. Instead of simply getting smaller, something far more interesting happens. The hull of the ship, the lowest part, disappears first. It seems to sink below the waterline. Then the deck and lower masts follow, until finally, only the very top of the tallest mast is visible before it too slips out of sight. We can replicate Eratosthenes' findings on a smaller scale. If you and a friend, located several hundred miles directly north or south of each other, were to place identical vertical sticks in the ground at the exact same time, you would find that they cast shadows of different lengths. The fact that they differ, and that the difference is predictable based on the distance between you, is powerful proof that you are both standing on a curved surface. Beyond the clues found on our planet's surface, the heavens provide one of the most compelling and honestly beautiful demonstrations of the Earth's true shape. This captivating event occurs when the Earth passes directly between the Sun and the Moon, casting its own shadow onto the lunar surface. What is remarkable, and what ancient astronomers noted with great interest, is the shape of this shadow. Regardless of the time of night or the position of the Moon in the sky, the shadow cast by our planet is always, without exception, a perfect arc. There is only one geometric shape that casts a perfectly circular shadow from any angle, in any orientation, a sphere. A flat, disc-shaped Earth would only cast a circular shadow if the eclipse happened at a specific time when the disk was perfectly face-on to the Moon. Anyone, anywhere, can watch this grand cosmic event unfold and see the evidence for themselves. It requires no special equipment, no complex calculations, and no trust in any authority other than your own eyes. Journeys around our world reveal evidence that, honestly, our ancestors could only have imagined. Airline pilots and navigators don't actually plan their routes using a flat map. Instead, they rely on what are called great circle routes, the shortest possible paths between 2 points on the surface of a sphere. For example, a flight from London to Los Angeles doesn't just go straight across the Atlantic. Instead, It arcs way up to the north, passing over parts of Greenland and northern Canada. This path only makes sense when you trace it on a globe. It's actually the straightest and shortest route you can take. There's also powerful evidence in the stars themselves. In the northern hemisphere, the North Star, Polaris, is always there. The further north you go, the higher Polaris appears in the sky. But as you head south toward the equator, Polaris drops lower and lower until it finally disappears as you cross into the southern hemisphere. Down there, an entirely new set of stars and constellations, like the Southern Cross, comes into view. This gradual shift in the night sky just can't happen on a flat Earth. The fact that there are separate northern and southern constellations is a direct result of standing on a curved surface. For thousands of years, people could only figure out the shape of our world through clever observations from the ground. But in the mid-20th century, everything changed. We developed the technology to leave our planet, to travel out into the darkness of space, and to do something no human had ever done before. Look back. The picture they took, known as Earthrise, shows a beautiful marbled blue and white sphere rising above the gray lunar landscape. It's honestly one of the most powerful and iconic photographs ever taken, a moment of profound revelation for all of humanity. Since those pioneering days, we've gathered an overwhelming wealth of visual evidence. There are countless photographs and hours of high-definition video taken by astronauts on the International Space Station, showing the Earth rotating below as a magnificent dynamic sphere. We have images from satellites in geostationary orbit that show the full illuminated disk of the planet in a single frame. This isn't just one piece of data from a single source. It's a continuous, verifiable stream of information from multiple agencies and nations all over the world. We've taken quite a journey through history, from the philosophical ideas of ancient Greece all the way to the direct observations of the space age. We've explored the logical reasons why some folks believed in a flat Earth and looked at the simple, repeatable experiments that anyone can try. Now it's time for you to pause and reflect. The goal here isn't to dictate what you should believe, but to encourage your curiosity and critical thinking. So we've presented several lines of evidence today. Which one sticks with you the most? We really encourage you to share your thoughts. The journey of understanding is something we all share, and real dialogue is a crucial part of it. By talking about these ideas, we can sharpen our own understanding and learn from each other's perspectives. Science is a conversation, not a monologue, and every curious voice adds something valuable. Our exploration of Earth's shape brings us to a simple yet really profound conclusion. The world we live in is, without a doubt, a magnificent sphere, a globe spinning through the cosmos. Each piece of the puzzle fits together to create a single, coherent, and honestly beautiful picture. They all point to the same truth. So, let's carry forward the spirit of the great thinkers who came before us, the curiosity of Eratosthenes, the courage of Magellan, and the awe of the Apollo astronauts. Let's keep looking at the world with wonder, asking questions and seeking answers that are rooted in the real, tangible world and universe. The compass that guides us on this journey of discovery isn't belief or tradition, but our own natural curiosity, guided by the needle of evidence. In the end, our planet isn't diminished by our understanding of it. It actually becomes even more wondrous. To know that we live on a vast, rotating sphere, a living world in the silent expanse of space, is a source of real humility and inspiration. By embracing evidence and nurturing our curiosity, we do more than just confirm the shape of our world. We affirm our place within it and continue the timeless human quest to understand.